tutorial, we will walk step by step on how to create a page object model design pattern. It consists of page object classes and test classes. I will start from scratch with Selenium using TestNG annotations, TestNG assertions, and object-oriented principles from Java. Some of the concepts were covered in previous tutorials. All of the code from this tutorial and previous tutorials will be on GitHub. There will be 5 TestNG annotations. The annotations are before class, after class, before method, after method, and the test annotations. When it comes to assertions, they help verify our test. They verify if the test passed or if the test failed. In Java, there are 4 object-oriented principles. The principles are encapsulation, inheritance, polymorphism, and abstraction. Our focus will be encapsulation and inheritance. Encapsulation keeps the data and the code that manipulates the data safe from outside classes. Inheritance is a process that allows a class to inherit the attributes and methods from another class. Polymorphism is the quality of an object to take on many forms. Abstraction is a technique that shows some details and hides other details. Page object model, that is the design pattern that uses the object-oriented principles. The advantage of a page object model is separating elements and interactions from the test scripts. There are 3 benefits to using the page object model design pattern. Those benefits are reusability, readability, and maintainability. Now, let's create our page object model design pattern by going to the IDE. Let's create the page object model design pattern starting with the structure. In this project, we have a source src directory, and it has 2 subdirectories, main and test. Main is used for the base page and page object classes. Test is used for the base test and the test classes. We will start with the main directory. Expand main, and we see Java. Right-click Java, new package. The name of the package would be LambdaTest.pages. And before LambdaTest, we write com dot. Now, let's create our Java class by right-clicking the package for pages, new Java class. The name of the class will be BasePage. The purpose of a base page is to have common methods for all of the page object classes. It's not required, but I recommend the base page because it helps with the dry principle. Dry stands for don't repeat yourself. We do not repeat the same methods in our page object classes by having a base page. For example, every page object class needs a driver. So we write public static web driver driver. Import web driver. After import web driver, we know the purpose of a web driver is to control the browser. Therefore, we set the driver by writing public void set driver, then pass in web driver. After passing in web driver, we're going to now write base page dot driver equals to the driver. For Selenium automation, there are 2 key steps. The first key step is to find the web element. The second step is to perform an action on the web element. There will be different actions, but we will always find the web element. So let's create a common protected web element to find. The by class is used as a locator to find web elements. That's why I passed in by locator as the parameter. Import web element and also import the by class. The by class is used to find the web elements. So now that I have the by class, here is the interesting part. Web element is the return type because driver.findElement and passing in the locator returns a web element. That's why the return type is a web element. Let's go to the application under test, which is Selenium Playground from LambdaTest, and walk through the test script. From this home page, we will click the Bootstrap Progress Bar link. Click the Start Download button. Wait for the progress, then get the download completed message and 100%. Notice the test script will click the button and get a message. Let's go to another page like the jQuery download progress bars from the previous tutorial. In this page, we also click the Start Download button and get a message. The message we got in the previous tutorial was called complete soon as this percentage finish. So those two pages have two common methods. They click a button and they get a message. So for our base page, we are going to write a method for clicking a button, such as protected void click. Pass in the by locator. And we're going to find the locator. After finding the locator, we're going to click. This will click the button, but using this method, we'll click anything such as a link and a button. Do you see how I called find? This find method helps us to not write driver.findElement every time we are trying to find an element. Plus, we write less code to perform the same action. That helps with the drive principle that I mentioned for as don't repeat yourself. We do not have to repeat this same driver.findElement in our page object classes. We only need to call the find method the same way we called it in this base page. The other action for both pages was getting a message. Selenium provide a method for getting a text from an application. So let's write protected string get text. Also pass in the by locator. And we find the locator, then get the text, which is that Selenium method I was just speaking about. It returns a string. So put string and with any name like text. Sometimes I like to print the value for debugging purposes. So let's write the statement for printing text, and I'm gonna write text after that part, and we're going to return the text. That's it for the base page. And with that part, we have the method for getting the text and the method for clicking. And we have that first step to always find the web element. And these are the actions, clicking and getting the text. Now, let's create the page object classes, starting with the home page. Right-click pages, new Java class. The name is home page. As a convention, I prefer to name the class with the same name as the application page. Here is the object-oriented principle of inheritance when I write extends BasePage. This means the home page inherits class members from the base page. Therefore, BasePage is the parent class and home page is the child class. Parent class is also known as the superclass, and child class is also known as the subclass. On the AUT homepage, our test script will click the Bootstrap progress bar. So let's inspect that link. We see it has an A tag, href attribute, and class attribute. Let's find this element using Bootstrap progress bar. Go back to the IDE and write private by Bootstrap progress bar equals by link text, then pass in that value. This is the other object-oriented principle of encapsulation. We make the variables private and the methods public. As a result, only methods in this homepage class can access the variables. For example, it is best to create a transition method. The return type is Bootstrap progress bar page, and the method name is click Bootstrap progress bar. So the reason why I create a transition method, and it's called a transition method, because on the home page, look what happens when I click Bootstrap progress bar. The page transitions from the home page to the Bootstrap progress bar page. Whenever you click a link or a button and the page changes, then it is best to create a method to reflect that change. That's why we call it a transition method. We finish this method by writing click. Notice the IntelliSense shows click by locator. This click method was created in the base page. However, the home page object has access to click because of inheritance. Now we pass in Bootstrap progress bar and return new Bootstrap progress bar page. And let me insert some more lines. Bingo. Bootstrap progress bar page is red because we have not created the Bootstrap progress bar page object class. So let's go back to the project and right click pages, new Java class, and the name will be Bootstrap progress bar page. It also extends BasePage. Go back to the home page object, and now we no longer see red because we have created that class. I spoke about how private means only methods in this class can access variables. A public access modifier means any class in this project can access the method. If I go back to the base page, we see public driver. We also see public set driver. They are public because we want all classes to access the driver. However, find, click, and get text have a protected access modifier. They are protected because we want only the page object classes in this pages package to access methods in the base page. It's all about protection to prevent code smells and spaghetti code. Therefore, the test classes will not have access to find an element, click an element, or get text from an element. In fact, our test classes should not have access to call the Selenium WebDriver APIs. That's a quote from Simon Stewart. Simon Stewart is the creator of Selenium WebDriver. Let's inspect the Start Download button. And it has a value of 𝑑WN_BTN. So I'm going to copy this value, then go back to our IDE. The Bootstrap Progress Bar page. Then for the variable, let's write private by start download button equals by ID. Then paste in the value. Now that we have pasted in the value for the field, which is the variable, let's also create the method called public, if I can spell it right, public void click start download button. We're not going to pass in no parameters because we only clicking the button and it does not need any parameters, but the action is click. Then pass in the field name of start download button. After clicking the button, we need to get the percentage that shows 100%. And we also need to get the message of download completed message. Let's start by inspecting 100. It only has a p tag with the class attribute, and the value for the class attribute is counter. We can find this using CSS selector. So let's write the dot operator, the dot, because it is a shortcut for class. Then we write counter, and bingo, we found the element. So copy this value, go back to the IDE, then write private by progress bar percentage by CSS selector, then paste in that value, which is dot counter, then add the semicolon. Now that we have that field, we can write our method to perform an action, and we are going to write public string. The return type is string because it returns a string value. The name of the method is get progress bar percentage. And we're going to write return get text. And the text we want is from the progress bar percentage field. Recall, we must wait a few seconds before the percentage shows up. So let's write an explicit wait statement before we return the text. For explicit wait, we write WebDriver wait. Wait equals new WebDriver wait. And we're going to pass in the driver on the next line to make room so everything shows up on this screen. Driver duration dot of seconds. And the number of seconds we want to allocate is 5. That will be the maximum amount of time that we wait for the element. Now we have our explicit wait. Last on this page, we want to wait until an expected condition. And the expected condition we are going to use is visibility of element located. Then we pass in progress bar percentage. And let's add this to the next line also because it's way too far on that line. Now that completes the explicit wait statement. In the AUT, we have one more element to inspect, and that is the completed message. We see it has a P tag. The class attribute has more than one value. Therefore, we can verify this element contains only one value. How about we use this by writing 2// P, which is the tag name. Open and closing square brackets, contains. Then the parentheses. Within the parentheses, we add the class attribute, followed by a comma, 2 single quotes. And now we're going to look for one of those values, which was success. That's all we need for using the XPath to find that value or that element. So copy the value and go back to our IDE. Now I'm going to write private by, a name can be completed message equals by XPath. Then paste in the value. Now we can go to our base test because we are finished with the base page, home page, and the BootstrapProgressBarPage object. For the base test, that's when we include the TestNG annotations and take a screenshot. We covered the annotations and taking a screenshot in previous tutorials. Let's go to the test directory. Right-click, Java, new package. Name is com.lambdatest.test with an S. Bingo. Now we right-click this package, new Java class, and this name will be BaseTest. We start with some variables, and those variables will be private web driver, so we can control the browser. Import WebDriver. Next is protected BasePage with a reference of BasePage. After BasePage, let's add protected home page. Last, we're going to write the URL, which is private final string AUT URL, application under test URL. Final is optional. It makes sure we're not able to change the URL. Let's go to the application under test and get the URL after I import base page, import home page. Now let's go to the AUT and get the URL from the home page. Copy, and we paste the URL. For our base test, first annotation will be to set up our test classes. So let's write at before class, public void, setup, web driver manager dot chrome driver dot set up. Web driver manager automatically manages our driver. This helps us to not write system.setProperty. Web driver manager is more effective than system.setProperty because it automatically manages our driver. But system.setProperty, we have to manually manage our driver. Next step is to create an instance of Chrome driver with driver equals new Chrome driver. Bingo. After creating our instance, we can maximize our window with driver.manage.window.maximize. Bingo. The second annotation will tear down our test, and we do that by quitting the driver. After class, public void tear down. Now we write driver.quit. The next two annotations are for each method. These two annotations, before class and after class, were for the class. For the method annotations, let's start with before method. There I go. Public void load application. And we are going to load the application with driver.get. And we will pass in a URL, which has the value of the URL. Now, let's create an instance for BasePage. New BasePage. Bingo. After creating an instance, we set the driver for each test by writing BasePage dot set driver, then pass in the driver. The next statement is not required, but helps us to bypass creating an instance in every test. And we bypass creating an instance in every test by writing homepage equals new homepage. The last annotation for our base test is after method. And it will take a screenshot of each test that fails. Since this was already covered in a previous tutorial, let's go copy that code from this take fail screenshots class. And I'm going to copy all the way from public void to the last curly bracket and come back to base test, then paste. Bingo. Let's go ahead and just walk through this code right quick for people who may not have seen the tutorial that covered taking a failed screenshot. For the first, we get the status, and if it is a failure, then take a screenshot using the interface, take screenshot interface from the second statement. The third statement gets the screenshot of an output type for file, then assign it to source. Since we have a file source, we also need a file destination, which is the screenshots directory. If you want to, you really don't need to write file destination. You can only use new file to start your screenshot directory. The last part is the try catch block to handle the file by copying from the source to the destination. Let me go to the screenshot directory and give you an example of what was captured in that tutorial. If I go to screenshots, then open test simple form demo.png, here's a screenshot that failed. For our page object model test, let's right click the test package. I'm going to minimize that. New, and then I'm going to select Java class. And for our test, the name will be ProgressBarTest. It will extend BaseTest. Let's import the BootstrapProgressBarPage with an object reference of progress bar page equals new bootstrap progress bar page. The test annotation, public void test progress bar percentage. Now we write our steps. On the home page, we click the Bootstrap Progress Bar link. After clicking the Bootstrap Progress Bar link, our test will be on the Progress Bar page. From the Progress Bar page, we click the Start Download button. At this point, the Progress Bar page will take some time to return the completed message. And when we get the completed message, we are going to assign it to a string. Now for the completed message, let's go back because I did not add that part to our page object. I don't believe. Yes, we stopped at get progress bar percentage, but let's go back and get the message. So I'm going to come back to Bootstrap Progress Bar, let it run, and inspect the message. And we see, yes, I did put that. What happened, I forgot to write the method for getting the completed message. So let's add that part right quick. So I'm going to do it real quick and do public string get completed message. And I apologize because I forgot to get that message. And let's just copy and paste the explicit weight and change progress bar percentage to completed message. And we're going to return the completed message after we get the text. Bingo. Now for our test, we're going to get the completed message and assign it to string called actual message. And now that we have the completed actual message on the progress bar page, let's also get the progress bar percentage and assign it to a string called actual percentage. Bingo. Now let's walk through these steps right quick because I went back and I had forgot to write that completed message. So let's walk through this test right quick. On the home page, we will click the Bootstrap Progress Bar link. At that point, we are now on the Progress Bar page. And by being on the Progress Bar page, we now click the Start Download button. When the Start Download button is clicked, we wait a while, so we added the explicit wait statement to get the completed message and also get the progress bar percentage. The plan is to verify two values, so let's use a soft assert and not a hard assert. The difference between hard assert and soft assert is a hard assert will stop execution and will not continue executing the next assert statement. That's if it fails. However, a soft assert will execute all assert statements if there is a failure. So at the top, let's write soft assert. Soft assert equals new soft assert. After, we're going to put in the string expected message. Because we get to the point we're going to verify the string expected message is download completed with an exclamation point and add the semicolon. The message for the percentage is expected percentage equals. Let's make it fail on purpose. So let's put 1000%. So we see it fails. Now for the assertions, we're gonna put soft_assert.assert equals. And for the first one, we're going to assert is the message. We're gonna make sure that the actual message and expected message are the same. On the next line, if they're not the same, let's write the message is not complete or correct. Now, this will also fail because download in the application is spelled wrong. And the second failure, we talked about that because it's gonna have 1000% that we expect, although the application returns 100%. So for the soft assert, let's put assert equals actual percentage, expected percentage. And we're going to put the message on the next line. And the message would say percentage is not 100%. Bingo. Always remember to add soft assert all at the end. If assert all is not at the end, then every test would pass automatically. Now, let's run. We see a yellow icon because the test failed. In the console, we see assertion failures. One for the message is not correct, is not complete or correct. Expected download completed, but found download completed without the N. The other message is percentage is not 100%. Expected 1000%, but found 100%. We can also look at the screenshot. Go to resources, screenshots, and we're gonna open up test progress bar percentage. In this screenshot, we see it shows 100%. Yes, and the completed message does not include the letter N. Let me maximize this just a little bit. Okay, so now let's make the test pass by going back to ProgressBarTest, remove N from the expected message, and also make 1000% to be 100%. Let's run. This time the test should pass, but let's make sure. Yes, the test passed. In the console, we see the text that shows download completed and also 100%. That's it for page object model design pattern. Thanks for watching, and I will see you in the next video where we will talk about the parallel testing and data providers. If you would like to learn more, then make sure to follow the blogs at www.LambdaTest.com/blog and community.LambdaTest.com. In addition to the blogs, you can earn a certification at www.LambdaTest.com/certifications. Get educated, get recognized.